Graph logarithmic functions. So I think that it's kind of fun to graph these. This may be where I am a little bit of a math dork. Well, not a dork because math is awesome. But we have to graph this y equals log base of 1/3 of x plus 1 and then minus 2. So the first thing we try to identify is if this graph has any shifting happening. So our shifting numbers, we have this x plus 1. Because it's plus 1 in with the x, we know it's shifting our x values, which is horizontal, and we want to remember we have the tricky x, so it's actually going to shift the opposite direction of what we see. So we see x plus 1, but we say, well, it's tricky, it's going to go to the left one spot. And then this minus 2 on the end is our vertical shift, very straightforward. Because it's a minus 2, we will shift down 2 spots. So the next thing we're going to do is say, let's make a table of values for this without the shifting numbers. If we were to cover that up, we would have this y equals log base of 1/3 of x without the plus 1 or the minus 2. And we'll do a table of values for this. Now, we can't just grab our calculator because our calculator operates in base 10 for logs. So the easiest way to approach this is let's take it out of log form, put it into exponential form, and make our table of values from there. So to get it into exponential form, identify our base. That's where we start. Our base is 1/3. Raised to get the exponent, that comes from the other side of the equal sign. So 1/3 to the y power equals whatever we were taking the log of, which is x. So we will do a table of values for this function right here. Now, approaching this a little bit differently, because we're taking 1/3, raising it to the y power, it's much easier for us to plug in values for y to see what we get for x, and then we'll just plot these points. So if we have 1/3 to the negative 2 power, I'll just do that one really quickly right here. 1/3 to the negative 2. This is that trick with a fraction raised to a negative 2 power. The shortcut way is we can flip our fraction, 3 over 1, and then give it the positive exponent. So we have 3 squared over 1 squared, or just 9. 1/3 raised to the negative 1 power, would flip it, give them the positive 1 exponents, and we would just have a 3. 1/3 raised to the 0 power is 1. 1/3 to the first power is 1/3, and 1/3 squared is 1/9. So here are the points that we're going to plot. Again, just approached it a little bit differently. We plugged in values for y to get the x, but now we're just going to plot the points we see. So our first point, we go over 9, down 2. So over 9 puts me off on the edge a little bit, but I'm going to end up right around there. Over 9, down 2. Next we go over 3, down 1. And then over 1, up 0. We don't go anywhere there. Then let's go a third and up 1, and then just a ninth and up 2. So here is our graph before the shifting. Now remember, the log functions have that vertical asymptote. If I just sketch this in real quick, here's our vertical asymptote at x equals 0. Now our shifting has us going to the left one, which means this asymptote is actually going to shift in pieces, apparently, to the left one spot. That's where our new asymptote will be. And then we just take each point and shift it to the left. One spot, and then down 2. Let's not forget that. So if I just take every point to the left 1, down 2, and then I cross off the old point I just switched, and I'm just going to go along my curve. To the left 1, down 2, cross off my old point, left 1, down 2, to the left 1, down 2, and then to the left 1, down 2. And now we have our new graph that we can draw in. It follows this curve, and then it's going to just come right up next to the asymptote and go along that, ever so slowly, getting closer and closer. So there's our new graph with our shifting. The asymptote is that vertical line that I shifted in the beginning. Let's remember, vertical lines have an equation of x equals, and so x equals, it's a negative 1 right there. Now our domain is all real numbers, and if we look at the graph, everything is on the right side of that negative 1. So we'll say our x's are all greater than negative 1. And then our range, all real numbers, we were able to plug in, negatives, positive, 0. We put everything in for the range to get all real numbers. And there you go. How fun.